Okay, so now next question is block reduction technique. So according to this, if you can see, the question is using block diagram reduction technique, find the closed loop transfer function of the following system. So your requirement is to find the transfer function. What do you mean by transfer function? Output by input means you need is C by R. Clear? So it means C of S by R of S. So we just refer as C by R, not to make it more complicated while solving. And the problem I'm going to solve is just I'm giving you the solution, but in the exam you are supposed to write the statements. First write the statement saying where is the combination, then do the block diagram, then again say what is the combination, then again do the next block diagram, like that. So every block change you need a statement. Here I'm not showing the statement. In my notes the statements are there, so please follow them. Clear? I'm just giving you the explanation, that's it. So now, when you see this, what is your first observation? So first let me just pass by this. If I'm going like this, here the first line is going, it is G4. Here a summation is there, it is very complicated. So I can't solve this, I can't solve this, I can't solve this. Forget. Now this go like this. G1 is there. G1 is going to G3. And G3 is having a parallel element, G2. So simply you can say that these two elements are in parallel. When elements are in parallel, you will add them, right? So now what happens? G2 plus G3 will be your next block, right? So G2 plus G3. So now the block diagram is changed as G1 is here. This node will be gone because you added these two, and summation will be gone because you added these two. I said G2 plus 3 because it is plus plus, so both are positives. So this is G2 plus G3. So it is going to C, but there is a node, remember. So before G1 there is a summation and there is a node which is having G4. So this is my remaining block diagram. R. Always remember this signs. Never forget. If not, you will do a mistake. Now this is the next block. Now after seeing this again, what you can see? Again, these three are complicated. You can't solve. But these two are in series. Okay. So when these two are in series, you can say that you can multiply them. So you can multiply this. So yours will be summation will be summation because we haven't solved this. Node will be node because we haven't solved that. So this will be G1 into G2 plus G3 with C and R. This is G4 going to a summation, and summation is having a feedback H2 with a negative positive. So here this is positive and negative, and here we are having H1. Perfect. Now what else you can do? So this way you are done solving. There is no scope for you to solve. So finally these three complications should be solved. So they are very complex. So how can we solve? So as I said, for block reduction technique we are having certain rules, right? Here this summation, we can't do anything here because this summation is having two inputs. So I want to separate the summation, means I want to send the summation before the block. I want this summation before the block. So it means H2 will come this side. Now see, When the summation is moved here, H2 will come here. But you see, if I go like this, H is going, H2 is going, H1, H2. H1, H2 are going here. And if you see like this, it is like G4 and H2 are going. So it means H1 is having combination with H2. G4 is also having combination with H2. So that's why when you move the summation front, H2 should be given to H1 and H2 should be given to G4 also. So what will be your next block diagram? So next what you should do is, anyhow you are having your series element here, G1 into G2 plus G3. Summation will be summation. So to this what I did, I bought the summation before. So when I bought the summation before, to the summation I'm having 2. So H2 I should write here and H2 I should write here, because usually H2 is here. So I bought H2 here, H2 out. Obviously here we are having G4. So G4 will be there with a node, no problems. Here we are having H1. R, C. And never forget about your signs, positive and negative. Positive and negative. Okay? Positive, negative, positive, negative. Same signs you should go there. Now these two are in series. Then these two are in series. So here these two are in series, means G4 into H2. These two are in series, means H2 into H1. That will be my next solution, right? So G1 into G2 plus G3 with a summation. This is no change, but this became a series block. G4H2 with a summation and H1H2 with a node. This is plus minus, this is plus minus R and C. Now what is the next step? If you see here, from reference G4H2 is going to this summation, right? So first let me write these two summations as single summation, means G4H2 is going this way to the summation. So two summations are there, minus and minus. Okay, so G4 minus G4H2 into minus, means plus G4H2 is going here. So I want to separate it. So when I separated it, it will be like G4H2. This positive is positive only, but this minus minus became minus into minus plus. So from this summation I separated it. Done. Now from here H1 H2 positive is going with the negative to the summation, means positive into negative is negative, right? So that is another summation I am keeping. This is positive, so positive will be positive, but here positive into negative is negative. H1 H2 is gone to G1 into G2 plus G3. This one. Now how is it looking? These two are in forward, these two are in closed loop, right? GH means with negative feedback, G by 1 plus GH, right? And this is 1 with G4H2. So here 1 is going, A is going, B is going. So answer will be A plus B. Here A is going, B is coming back. So feedback. So G by 1 plus GH because negative feedback, and this is 1 plus G4H2. I am saying this as 1 because when there is no block here, it means one gain is there. So now these two I am writing them as 1 plus G4H2. So summation is gone. Then this one I am writing it as G by 1 plus GH. What is G? G1 into G2 plus G3 by 1 plus G1 into G2 plus GH. G I wrote, H is H1 H2. So this is my block. This is R, this is C. Now these two are in series, so I should multiply. So it will be G1 into G2 plus G3 into 1 plus G4H2 by 1 plus G1 into G2 into H1 H2. G1 G2 H1 H2 plus G1 into G3 into H1 H2. G1 G3 H1 H2. So this is my block. This is R, this is C. Therefore, C by R, this is my requirement, transfer function. So C by R is equals to, multiply this, G into G1, G1 into G1, G1 G2 plus G1 G3, right, into this one. So G1 G2 into 1, it will be G1, okay, first let me write G1 G2 plus G1 G3 into 1 plus G4H2 divided by 1 plus G1 G2 H1 H2 plus G1 G3 H1 H2. Now multiply these two also. That will be your final answer. Okay, so the block is reduced. You got a single block. This is your answer. If you multiply these two also, you will get full marks. So that's it. So first what happened? These two are in, these two are in parallel. So we added. Then these two are in series. So we multiplied. Then we said H2 is belonging to H1, H2 is belonging to G4 also. So we made H2 come back, H2 go here also. So H2 is gone here, H2 is gone here. Now these two are in series, these two are in series. So multiply. Now summations, two summations are there. So what I am saying, R is going with minus into minus, means positive. So I wrote it as positive, I separated the summation. Now here, plus H1 H2 is going to minus. So minus H1 H2. So I separated the summation. Now these two are forward, means A plus B. So I wrote 1 plus G4 H2. Then these two are in feedback. So G by 1 plus GH. So now these two are in series. So I multiplied them. Therefore C by R is equals to block. Done. This is another block reduction technique.